Hello, everyone. It is indeed a pleasure to welcome you all to this In Conversation with Stratview. Dear viewers, while many technologies have evolved within aerospace industry this century, be it AI in flight systems or say complex parts manufactured using 3D printing, there's only one category that stands alone as entirely new, the eVTOLs. And that's what this discussion is going to be about today. This is me, Deepak Tiwari, your host for the day, and joining us for the conversation are two very distinguished individuals, Dr. Robert Yancey and Mr. Deepak Agrawal. Let me start by introducing Dr. Yancey. Dr. Yancey has filled numerous roles in his career, including research, technology development, sales, management, business development, and executive roles. He currently leads business development for Hexcel in Americas, which includes advanced materials, manufacturing, and engineered products. He focuses particularly on emerging markets such as advanced air mobility and uncrewed systems, along with coordinating all defense related pursuits. He has a technical background in composite materials, composite mechanics and micromechanics, design optimization, additive manufacturing, finite element modeling, and non destructive evaluation. He holds a BS degree in aeronautics and astronautics from MIT, an MS degree in engineering mechanics from Virginia Tech, and a PhD in materials engineering from University of Dayton. He is an AIAA Associate Technical Fellow, Distinguished Service Award recipient, and Technical Excellence Committee Chair for SAMP, and member of the Board of Governors for the Utah Aerospace and Defense Association. Dr. Yancey, welcome to In Conversation with Stratview. Welcome, Dr. Yancey.
Thank you.
Also joining us today is Mr. Deepak Agrawal, a well-known market research consultant with over 15 years of experience in global mobility and composites industry. Holding an MBA in marketing and finance, Mr. Agrawal has led more than 200 strategic consulting projects and worked on 200 plus syndicated reports across various industries. He has worked extensively in advanced materials, especially composites and chemicals, across various sectors like automotive, aerospace and defense, oil and gas, construction, and recreational goods. Throughout his career, he has driven projects for both small firms as well as Fortune 500 companies, collaborating with many leading players in aerospace and composites. Welcome, Mr. Agrawal, to In Conversation with Stratview.
Thank you, Vyapak.
Now, to begin with, Dr. Yancey, the eVTOL industry, as we all know, generated significant optimism around in 2020 and 2021, right? But many companies have since faced delays in certification and operational timelines. So, how do you assess the current state of the industry? Do you think these setbacks are part of a normal maturation process for a disruptive technology like eVTOLs, or do they signal deeper structural challenges within the industry?
Yeah, I think, as I got involved in this industry about 5 years ago, that was a theme that you often heard, in that the certification timelines that are being advertised by these companies are way too aggressive. And, if you look at traditional, getting a vehicle certified, it takes roughly 10 years. The original the players at the time 5 years ago were saying, hey, we're going to use lean principles, we're going to use agile frameworks, all of these things that have been honed in Silicon Valley for software development. We're going to apply those capabilities, and we're going to get a vehicle certified in half the time, say 4 to 5 years. And we now hit that. Nobody's been certified. I think that there is a pathway for them to be certified in the 7 to 8 year time frame, which is still faster than the traditional process. But certifying an airplane or a new air vehicle is hard, and it should be hard.
Yes.
We want safety, and we want predictability and all of that, and that just takes time to go through that. So I don't think that there's anything structurally going wrong. I think the companies that have been able to raise sufficient money to keep them going through this process we'll just continue to go through the process, and eventually somebody will get certified, and these vehicles will get into the marketplace.
Correct. Joby, I think, has a fair chance of being certified first. Right.
Yeah, I mean, if you look at cash,
Mhm.
kind of on hand,
Mhm.
Joby, Archer, and Beta seem to have enough cash to
Yes.
get them through certification, and they've all been making good progress. And then you've got Wisk and Supernal here that continue to have the backing of their parent companies, Boeing and Hyundai, on that. So the European firms seem to be struggling more with cash on this. So we'll see if any of them make it through. But those 5 U.S. firms seem to have enough cash now to get through certification, unless it ends up taking 12 years. Some of them are going to run out.
Correct. So that's what I want to follow on. Okay, we've seen a lot of we've seen a number of leading eVTOL companies face significant financial setbacks also, right? So from your perspective, where did things go wrong for those companies? Were they primarily due to poor financial management, underestimated, say, certification hurdles, or broader market conditions like investors' sentiment shifting away from capital-intensive mobility ventures?
Yeah, I mean, as I've looked into this, I hear the term. It costs $1 billion to certify a new air vehicle, and it costs another $1 billion to certify the production process. So you're talking $2 billion. There's only a few firms that have been able to raise that kind of capital. So I think for the firms that have struggled financially, they just didn't raise enough money. The other aspect is, I wasn't involved in their pitches to investors, but if you look at investors in the software industry, the typical timeline is I invest now, company starts generating revenue in 3 years, and they're generating profit in 5 to 7 years, and I can exit and get a nice return on my investment. That's not the case in aerospace. I mean, as we talked about, it's probably going to be more like 7 or 8 years for certification, so they can't generate any revenue until that time frame, and then it's probably another 5 years in operation before they could start turning a profit. So investors have to be a lot more patient with this market. Returns can be significant, if the overall market is successful, but it's just a different timeline. And so for some of the companies that may be strapped for cash, maybe they promised a quicker return on the investment to their investors, and investors are holding firm and not giving them more money until they meet some of these timelines. Okay,
understood. Now that's really an interesting perspective, because we get to think from the investor's perspective. I really appreciate this example of the software companies, other industries versus the aerospace, right? Following up on that, Dr. Yancey, do you see more players from the automotive industry entering this space? Also, do you think entries will be more in the form of investments, like Toyota investing in Joby, or they'll be looking to launch their own models like Honda is trying to?
Yeah, I think it remains to be seen. I think the big question mark right now is, what is this market going to look like in regards to market adoption?
Okay.
I remember, I'm dating myself, but I remember all the hype that came up around the Segway. I think most people know what those are. They've seen them at trade shows and stuff. All the hype was everybody's going to have one. It's going to revolutionize urban transportation. We're not going to be driving around in cars anymore. We're all going to be running around in Segways and so forth. Segways had a market, but it didn't develop like the original developers thought, or the people that were hyping that industry. So I think it remains to be seen, is eVTOLs going to be a novelty form of transportation that's used occasionally? Maybe it's a premium experience type of activity, or does it become mainstream that it's as accessible as taking an Uber or a taxi there. And I think, that will somewhat dictate what the automotive industry does. If it becomes a very common form of transportation, it potentially can eat into the markets of the current automotive companies. And so they would be smart to enter the market and, become the urban or suburban transportation solution, whether that's on the ground or in the air. And I think that's why Joby and Stellantis have stepped in, thinking that could happen. So let's get ahead of it and be prepared if that market happens. But if it becomes more of a niche kind of premium transportation, you probably won't see more automotive companies come in. I do think that if the market develops so that it does become a fairly large market where we're producing thousands or even tens of thousands of vehicles a year, I think the automotive industry brings a lot of technology in high volume manufacturing that's going to be needed for this industry. And I know that both Joby and Stellantis, are working closely with Joby and Archer, respectively, on developing their manufacturing systems and so forth. And that expertise, I think, is very valuable and will be needed if this becomes a really large market.
Correct. So let's just hope, let's keep an eye on the market and see how it unfolds, whether it becomes a niche product or it becomes household technology. All right. Dear viewers, before moving on, we'll be speaking to Mr. Agrawal about the market, but I would like to tell you that please drop your questions on LinkedIn live chat, and I will be picking your questions live and will be asking both of our experts. So please feel free to drop your questions on LinkedIn live chat. Now, coming to you, Mr. Agrawal. Mr. Agrawal, I've seen consulting firms have published, widely varying projections for the eVTOL market, right? Ranging from hundreds of billions to even trillions of dollars by 2040, right? So given your hands-on experience, how do you reconcile these disparities? I mean, beyond the noise of these trillion-dollar forecasts, what does your analysis tell us about the realistic commercial potential of the eVTOLs?
Thank you, Vyapak. And that's actually, one of the major concerns before all investors, raw material suppliers, tier players. They really would like to understand, where exactly this market will head in coming years. The reason being that, because aerospace industry, even, as Robert mentioned that, aerospace industry is quite different than any other mass volume industry. Reason being that you need a lot of certifications, and these certifications are crucial because that actually drive the safety of passengers, safety of pilots, and and the other stakeholders. So that's how this industry is very much different. And many of our clients, they would like to understand where exactly this market will head in coming years. And if you look at and if you talk about all companies, those are active in eVTOL manufacturing, they have their own projections, which is extremely rosy. Like if you believe that there would be thousands of eVTOLs on market in a couple of years, but that's not the real case. So we have done a thorough analysis on that, and please, can you please share that slide? So where we have done a thorough analysis. Can you please move to next slide?
Just a second. Are you not able to?
Yes, I can. Just a moment. Yeah, not sure I'm able to move out.
Which page should I go to?
Yeah. So can you please move to next slide?
Just a second.
Yeah, that's slide number 3. Yeah. So on basically, what exactly in order to resolve or solve this challenge, we took a unique approach. So we started mapping out a lot of companies who entered this market or this beautiful innovation category. So we mapped more than 500 companies, trying to understand which stage they are in, what exactly they have been doing, what kind of strategic alliances they have been, trying to form. So ultimately, we figured out some major companies that are active in that actually, at our advanced stage. Can you please move to next slide?
Yes, I
Yeah,
can.
I can do that, I believe. Here, now I have it. So in order to do that, after doing this mapping, we have done a lot of interviews. So over the time, we have done 150 plus interviews, specifically, trying to understand the eVTOL projections. And to assure that, we have talked across the value chain, not only talking to, companies that are manufacturing eVTOL or that actually engaged in eVTOL manufacturing, but we also talk to tier players. We also talk to industry stakeholders. We also talk to raw material suppliers, and that's really important. Why? Because they have their own way of understanding the market. Just talking to one category may mislead us. So that's the reason we talked across the value chain in order to get the complete view of market.
Correct.
And that's how we come up with our own analysis. So we have mapped the trend last 5 years. What are the deliveries took place for eVTOL? So whatever deliveries if you talk about before 2024, majority of them is e-hang one. So for there are a couple of deliveries done by Joby and Archer, one from Autoflight, and rest everything's eVTOL. And if you look at the overall projections, we anticipate there would be next 5 years there would be a very slow growth. Reason being that they need a lot of certifications in order to reach at commercial stage production, and that takes around 7 and 10 years. Even Robert mentioned that industry takes around 7 to 10 years in order to get the certification. And once they achieve that certification, then there would be a next level of production, and where there would be a lot of increase in terms of production rate. So basically the next like if you talk about 2030 or 2033 onwards, we see a lot of growth. But before that, there has been a gradual increase in terms of eVTOL deliveries. Again, what we see that as of now, China and US lead. China already started manufacturing and delivery. Definitely, I'm sure they are not on sky. US already, lot of major companies, they still are quite having enough money at their bag in order to run their business and get certifications. Europe already is in trouble, so a lot of companies, both two major companies already got bankrupt. Volocopter being acquired by another company, Lilium failed to get investment and again filed bankruptcy. So overall, if you see that, by 2040, we anticipate close to 2,200 eVTOL deliveries are going to be delivered, ultimately having a value of around 3.2 billion US dollar. So we are not saying that it's going to be 1 trillion market in next 15 years. So we are quite pessimistic in terms of production, understanding the challenges that industry has as of now. They need a lot of vertiports, they need infrastructure, they need pilots. A lot of challenges are there. And one of the most biggest challenges that ultimately they have to compete with Uber or other mobility, or maybe trains, in order to make them affordable. So that's the reason we believe there won't be so much rosy picture that it seems. So among type of deliveries, Volocopter as of now leads because of the e-hang one. But if you talk about the coming years, Vector and Lift Cruise are going to play a big role. And if you talk about the value-wise market, the pictures would be entirely different. The reason being that Vector and Lift Cruise are more expensive. So
Okay.
if you talk about 2040, 70%, even 85% of the market would be captured by Vectored and Lift Cruise. Multicopter would not be that huge. In terms of unit, it would be huge, but in terms of value-wise market, Vectored and Lift Cruise are going to play a bigger role. Among regions, China currently leads. But if we talk about the coming years, North America and Europe are going to play a big role, especially in terms of value-wise market. Again, the reason being that majority of companies, they're working on vectored and lift crews, which are much more expensive than multi-copter one, which actually they're going to help them in order to make more money than other regions. But this is really impressive that the current landscape still giving lot of promises. Companies are getting certifications gradually, and some companies are still able to catch lot of investments. Ultimately, will help this market to shape with a bigger picture in coming years. So just one more slide I would like to present. Yeah. So one interesting thing is that if you talk about aerospace industry material chain, uh, composite has been playing a very good role with all the next generation aircraft. But if you talk about UAM having the maximum composite content. So 70 to 75% content is of the aircraft weight is UAM. Whereas if you talk about all Boeing and Airbus aircraft, they have around maximum, they have 50 to 53% composite content. And based on our projections of eVTOL deliveries, we anticipate that by 2040 there would be around 9 million pound of composite material demand would be globally, and majority of them would be thermoset based, and some would be thermoplastic. So there are a couple of companies who are working on thermoplastic,
Okay.
and which will drive the market. But overall, thermoset will lead in coming years. So thank you.
Okay. Wonderful. Thank you, Mr. Agrawal, for those engaging, interesting slides and for clearing the air around the realistic commercial potential of eVTOLs as well. So, and also, thank you for sharing the share between thermoplastic and thermoset composites. Dear viewers, now that we have discussed the overall eVTOL market comprehensively, let's now look into the material side of things closely. So I'll pick it from where Deepak left, Mr. Agrawal left. As we know, we believe, and even Deepak said right now, the most of the eVTOL OEMs currently are relying on thermoset composites, right? However, thermoplastics offer compelling advantages for high rate production and recyclability. So, given the industry's scaling challenges, how soon do you foresee a viable transition to thermoplastic composites? Mr. Yancey.
Yeah, interesting question. I would say, about 5 years ago when I got involved in this industry, most people I talked to said we're going to start with thermosets. Version 2 of the vehicle will be thermoplastic. Stated all of the obvious reasons. We don't have enough autoclave capacity in the, to be able to manufacture thousands of vehicles using autoclaves. The industry is very focused on sustainability with electric propulsion and all of that. Thermoplastics, can be recycled and all of that. But I will say, honestly, I've heard all the way back to my college days at MIT, I heard that thermoplastics are the future. Thermoplastic composites are the future. And they've never really gotten into the mainstream. Yes, there are applications. They, there's material that you can procure out there. And there are times when thermoplastic composites make good sense. They have added toughness and they're more easily molded and so forth. But in terms of making it onto primary structure aviation, you don't really see that. But I thought, okay, well, maybe the eVTOL industry will be the one that will really drive this into the more mainstream. But over those 5 years, there's been a lot of technology development in regards to out-of-autoclave thermoset material systems. There's, some other technology that's starting to emerge that would allow you to, get out of the autoclave for more traditional thermoset composites. There continues to be activity around thermoplastic composites, but like in Europe, they've been doing research on trying to use resin infusion for an entire wing structure. So I don't think it's set as to what material system for the next version. It could be a thermal set, could be a thermoplastic, probably more likely a combination. Use thermal set where it makes sense, use thermoplastics where it makes sense, but utilize some of these technologies that are now out there and continuing to be developed to allow you to do thermal sets in a more high volume manufacturing environment, no autoclave, faster cure cycles, but still maintaining that kind of aerospace quality.
Okay. We've got a comment from Kane on LinkedIn. I'd like to take it up for Mr. Yancey. How do you see thermoset prepreg, thermoplastic prepreg, and 3D printing technologies being implemented into eVTOL part components? Which would be the most promising? Kane asked this on LinkedIn live comment.
Yeah, I think prior to my previous comment in that I think there's advantages of all these material systems. 3D printing, I think, especially if you're getting into higher volumes where there's complex geometry or maybe complex tooling that might be required, where 3D printing might be less expensive. Do I see a pathway for a 3D printed fuselage or wing? Not in the near future. I think there's a lot of certification hurdles with that, but I think for parts in the cockpit, for example, you could customize that for different regions of the world, for example, fairly easily with 3D printing, and it's not a structural part. If it fails, it's not going to cause loss of life and so forth. So I just think there's. And the thing that is it's not just the eVTOL industry. If you look at commercial aviation, they want faster processing. They want higher volume manufacturing methods. They want to get out of the autoclave if they can. They want to make integrated structures, large integrated structures. So that industry is also driving a lot of advancements that I think benefits both industries.
Okay. Correct. Now, before moving on, we'll just take one more question. Yeah. Jeffrey asks, can we expect eVTOL to use the same certified prepreg and adhesives used by commercial aircraft OEMs? Does this save them time or money on certification process?
Yeah, I mean, I think all of the major players now are either using material systems that have previously been certified and qualified, or have recently completed a full qualification on this. To qualify a new material for aerospace, it costs anywhere from $500,000 to $1 million per material form, and can take 18 months to 2 years to be able to complete. So these eVTOL players now that are leading the pack, they're trying to move fast and so forth. And so, in most cases, they selected material systems that had some sort of pedigree already so that they didn't run into significant delays in the certification process. Do I think new material systems will be developed for this industry? Possibly. I think if it gets into really high volume manufacturing that really exceeds the kind of volumes that commercial aviation uses today, yes, I could see some new material systems being developed specifically for that market that may not be used in the large market. But I think it just remains to be seen how large this market's going to turn out to be.
Okay. So since we were taking Jeffrey's questions, Jeffrey has another question. I think this one is for Mr. Agrawal. Mr. Agrawal, Jeffrey asks, can you comment about the rough order of magnitude composite content and value per aircraft? I think he is asking what percentage of an eVTOL would be of composite and value per aircraft.
So typically, if you talk about any legacy aircraft, generally composite content was around 10 to 15%, except the two, which is Boeing 787 and Airbus 350, where the composite content was over 50% of their gross vehicle weight. But if you talk about, eVTOL, you have to make it very light. The reason being that, you need a short runway. You need, to move very fast, and you need to drive the entire vehicle on battery. So, and ultimately, you make the entire system very lighter. So, what based on like mapping of lot of companies, around 70 to 80% of the vehicle content is composites. And if you talk about the weight of the empty weight of vehicle, again that differs from the category to category. If you talk about a typical multi-copter, typically weight around 400 to 500 kg or 400 to 700 kg. Out of that, around 70% is composite content. But if you talk about typically vectored or lift crews of companies like Joby, Archer, and other ones, they have weight around 2,000 to 2,500 or 2,700. So out of that, 70% content per eVTOL is composites. So you can simply take out the ratio around 1,700 to 1,800 or 1,500 to 1,700 kg per aircraft. That would be the composite content for vectored or eVTOL, vectored and lift crews. But if you talk about multi-copter, it would be significantly lower.
All right. Got it. Understood. Thank you. Thank you so much for that response, Mr. Agrawal, and also Dr. Yancy for answering these questions. Moving on, dear viewers, please keep dropping your questions and the questions which we haven't taken yet. We will make sure to take them. Please drop your questions in the LinkedIn chat. Now, moving on, Dr. Yancy, we are now able to see an increasing number of strategic partnerships between eVTOL OEMs and composite material suppliers, right? Say, for example, the collaboration between Archer and your company, Hexcel, right? Or Overair and Torre, right? So, what is the significance of the eVTOL market for established composite material suppliers like Hexcel, right? Especially, what future opportunities is Hexcel looking to target within the eVTOL space?
Yeah, well, as Deepak just mentioned, the percentage of composite in terms of the structural content is very high in the 70% range. So obviously, if I'm a vehicle manufacturer and 70% of the weight of my vehicle is going to be from a supplier, I'm going to want to develop a good relationship with that supplier to make sure that I understand which material I should use, how to process that material, make sure that I've got reliable supply of that material, and so forth. So I think it's natural that these companies have developed these partnerships, and I think it's good. It's good for, I can speak from the material supplier standpoint. It's good for us to be engaged with these companies to not only know what their material requirements are today in the vehicles that they're trying to get certified and trying to, get this market established, but also know what they're thinking in regards to materials of the future so that we can take that feedback in combination with feedback from other customers, such as, our commercial aviation customers, and use that to develop, the material systems of the future that will be able to continue to move this industry forward.
Okay, got it.
Let me make one other comment. One other thing that Hexcel has been doing that I wanted to highlight, because I saw one of the questions that came up in the chat here, is in regards to what Hexcel's doing in preparation for the Utah 2034 Winter Olympics that we'll be hosting.
Yes.
And so we did get, so there is an organization here in Utah, relatively new, started out as the Utah Aerospace and Defense Association. It's now been rebranded to 47G, but really their focus is to provide a body that can advocate for the aerospace and defense industry in the state of Utah, which today, accounts for about 20% of our GDP in the state of Utah. So I had worked with that group to say, hey, this is an emerging market of eVTOLs. We've got the Olympics now that have been, announced for Salt Lake City in 2034. So why don't we put together a group of people and an organization to make sure that the state is well prepared for that event? And as you know, we talk a lot about certifying the vehicle, and that's a very important step. Okay, and then you got to certify the manufacturing and production process. But there are all these other things that have to come into play for this market to be successful. We need air traffic management. We need charging stations. We need support from the local community. We need vertical helipads, vertiports, where these can land. We've got to have the buy-in from all of the local regulatory agencies and so forth. And so Utah, with the support of Governor Cox, put together what we call Project Alta. And they have a full-time executive director who is an ex-administrator for the FAA, so very experienced with the regulatory environment. And they are working with local communities and with charging station providers and communities that want to have vertiports in their community and so forth. And so, and they've also developed test ranges and invited the eVTOL companies to come into the state in order to be able to test their vehicles. The use case in Utah is a little bit different than in New York City, where it's not just urban transportation. We've got a lot of rural communities that if there's an easier way to connect them with the urban, the Salt Lake metro area, that's a real benefit to the state and so forth. So keep your eyes peeled on Project Alta. A lot of good progress on that. And we hope that eVTOLs become a major part of the 2034 Winter Olympics.
Okay. Thank you so much for that response, Dr. Yancey. Also, I had this question to be asked, right? But since you mentioned all of this just now, I just put it here. If you look at aviation today, we have an entire ecosystem of service providers supporting the industry, right? OEMs like Boeing and Airbus, airlines, airports, air traffic control systems, and well-established maintenance and operations procedures as well. So, globally, how is this being addressed for the emerging eVTOL industry?
Yeah, like I said, it really does take a whole of industry approach, and I know other states have set up consortiums or communities to be able to help support the eVTOL and advanced air mobility industries. But at least the feedback we're getting from the OEMs that are visiting the state to understand what we're doing and to contribute, Utah is really the only state that's trying to look at the entire ecosystem and making sure that the entire ecosystem is in place and ready to be able to support this industry. So I think it is important. Obviously, the OEMs are heads down focused on getting their vehicles certified, but those that have sufficient cash are looking at these other issues in terms of the infrastructure and looking at how do we set up pilot training and where do we recruit the pilots, and do we operate our own airline, or do we partner with another entity that can be the operating entity for this and so forth. So there are a lot of things that have to come together. And the last thing you want is to have everything but one in place and have all the hype and the interest in this market and then have it slow roll out because one piece is, you've only got one vertiport within 500 miles. And so that really limits the ability to be able to showcase this market and what it can mean to people's lives and their transportation options.
Okay. It's really nice to hear that so many efforts are being made in the state of Utah. Coming back to my question about materials, right, that we were on before taking these questions. Uh, from your perspective, Dr. Yancy, considering the global landscape of composite materials, do you anticipate China emerging as a significant competitor to the US and Europe in supplying composite materials for eVTOL OEMs, similar to its trajectory in the other industries for carbon fiber, or do you think the US and European regions largely they'll be able to maintain their leadership in this crucial area?
Yeah, so China has added a lot of capacity in the
Correct.
last few years for carbon fiber. The quality of the carbon fiber is getting better, and they are, it is being used in industrial applications and drone applications and so forth. I think long term, I think they will face significant challenges in getting Chinese materials certified for vehicles that would be operating in the US or Europe. I think certification agencies would really scrutinize this, and you don't always get great access into the manufacturing plants in China. And for the FAA or EASA to certify materials that are going on a vehicle that they certify, they are going to want to thoroughly climb over the manufacturing facility for these materials, understand the quality control requirements and so forth. And today, those are still a challenge in China. If that changes in China and they open up their factories and so forth, yes, I could see a pathway for them to be able to supply materials to this industry. But I think today they're going to be limited mostly to domestic China production vehicles that don't have to go through a European or a US certification.
Okay, understood. So things in China are difficult as of now, despite their quality being good. So then, Mr. Agrawal, what does our research say about this? Which regions are expected to dominate the material as well as the overall eVTOL market in the future? Because right now China is dominating. They've certified the vehicles, right? E-Hang and Autoflight, they've got certifications. But what's ahead? What happens when the market matures?
So I'm completely aligned with Robert. So even what we believe that if you look at the past 5 years, China has added a lot of carbon fiber capacity, and if you track all the capacities, one thing you will find that majority of them are over 24K, which is not an applicable material for aerospace. You need 1K, 3K, 6K material. So where China still lacks. Second, definitely if you talk about the companies, those are manufacturing parts in China, so they may rely on these materials, Chinese carbon fiber, in coming years. But if you talk about US or European companies, especially the major ones, they keep buying carbon fibers from companies like Hexel or Syensco or Toray. The reason being that they have a years of experience. Second, majority of their products are already being certified for several commercial and military aerospace programs. So it's very easy for them to get certifications for those materials from FFA or ESA. So and once these materials being certified for certain programs, they keep stick with that. So there's actually not near term and long term, we do not see a major competition between Chinese carbon fiber and like companies like Hexel, Toray, or foreign companies carbon fiber. There's no competition, especially for aerospace industry. But if you talk about industrial, we do see a lot of competition, especially for pressure vessels or wind energy. These are the areas where price does matter. So where we see some challenge coming from China side, but high performance applications, including civil aerospace or military aerospace, including eVTOL. We do not see any competition in near and long term.
Okay, understood. So, Mr. Yancy and Dr. Yancy and Mr. Agrawal both are aligned on this, that we don't see China emerging as a competitor in composite supplying for the eVTOL industry. Now, we'll quickly get into the LinkedIn live chat, and we'll take a few more questions. Dr. Yancy and Mr. Agrawal, since we were discussing about the timelines, right? So David has asked this question: can you speak to the varied timelines of market launch between global regions?
Yeah, I mean, you've seen some announcements over the last several weeks. So I think Archer in the Middle East, and so forth. So you do see some of the OEMs launching partnerships with foreign governments where they believe they can get vehicles certified a little quicker, get them in operation, start understanding the use cases and the market and operation issues, and start toning in your production process and so forth. So I think those those activities will continue. You also see at least Joby and Archer, and I think maybe Beta is involved here in terms of partnerships they have with the U.S. Department of Defense, where they're developing military applications for these vehicles. But again, it's giving them an opportunity to be able to collect data, understand how the vehicles operate, use cases, and all of that. For me, I think the most likely time frame for an FAA certification certified vehicle is in the 2027 to 2028 time frame. Joby, Archer, and Beta are well along in the process, and doing piloted flights now and so forth. So, but as mentioned, certification process is hard. This is a new class of vehicles, so the FAA's got to also figure out, the issues that they need to be concerned with in the certification process. So I think we still have a couple more years of testing. But Joby, Archer, and Beta seem to have enough cash to be able to make it through that time frame. And so that's my best estimate as to when you're going to see a U.S. vehicle certified so that they can start selling and operating.
Okay. The takeaway from this is that we can see an FAA certified eVTOL somewhere in 27 and 28, right? So this also gives birth to another question in my mind. Doctor, why do you think China is ahead right now? How did Chinese OEMs like eHang, right, and Autoflight, how are they able to, get their eVTOL certified so early? I mean, we can take example of eHang. They have, they now even have a certificate, production certificate. Right.
Well, I'll just say it's certified in China, and those vehicles are nowhere near being certified in Europe or the U.S. Is that a bad thing? Again, they're going to collect data, kind of understand the market. Hopefully, there's no accident where there's a fatality involved, because I think that's overall bad for the industry in general. And so forth, but they do have less stringent certification timelines. I mean, I was in China 15 years ago and met with some of the certification agencies and so forth, and they just have a different set of rules that they go by in certification, and that works internally, but they're not accepted outside of China.
Okay, understood. Moving to the next question, Motoshi has a question. Is there any infrastructure development plan for implementation in a highly populated country like India and related safety? Or is it too early to think about this?
Well, just like Utah is not a highly populated state, but we've been taking a look at how is this going to benefit the communities that we have in Utah. I think most communities, whether they're urban, suburban, rural, and so forth, ought to be thinking about how these vehicles can, impact the quality of life of their citizens. So I know, in New York City, they've looked at how this is going to fit in with, getting people from JFK Airport to downtown Manhattan. I know that they're looking at it in Los Angeles, especially preparing for the 2028 Olympics and how they might be utilized there. So communities are looking at, how to integrate it. And I would encourage, in highly populated areas of the world like India, I think it's good for Indian governments and the Indian communities to start talking about, is this really going to be a benefit to us? Or is everybody just going to complain about, we've got these buzzing things over our heads and sometimes they fall out of the sky and we don't want them in our community. I mean, we're going to have to, and that's part of what's being done in Utah. It's engaging with the communities, helping them understand what these vehicles are, how they operate, what the types of use cases are, so that we can get the community to be accepting of these rather than being viewed as, hey, this is some rich person flying over my head, and I don't want them flying over my house.
Okay. Thank you for that response, Dr. Yancey. We'll take another question. This question is by Franklin, who asks, do you anticipate supply chain limitations for massive production of eVTOLs? And if so, where do you anticipate the primary bottlenecks to be at?
So if the market develops the way the leading companies have pitched it to their investors, which is this is going to transform urban transportation. There's going to be a demand for thousands of vehicles to be produced per year. These are going to be like Uber in the sky and so forth. There's multiple supply chain bottlenecks that will happen. Okay. And I've often talked about this. So one question is it the aerospace industry that steps up to produce the higher volume? They know aerospace, they know certification, and so forth. So, but they don't know high volume manufacturing. So they have to learn that. Is the automotive industry, which we've discussed, are they going to step in who understands high volume manufacturing, but doesn't understand composite manufacturing very well? Okay, so they would have to learn that. Or is it, players from both of those industries coming together to create a new entity? So that's on the production of the vehicles. There could be supply chain bottlenecks in materials. Right now, the carbon fiber material industry can support the volumes there, but if it gets into thousands of vehicles per year, there's going to need to be added capacity. Added capacity is expensive in our industry, and it also takes time. It takes a few years to be able to add that capacity. It's not like I can say, next quarter I'll double my capacity. So there needs to be a tight coordination, between the OEMs who are developing the industry and the supply base to determine when do we invest, because that's pretty important. You invest too early, you could go bankrupt. You invest too late, you're going to miss the opportunity. So really investing at the right time is important. And right now we don't have enough data to know when that right time's going to be. It's going to take somebody to be certified, maybe a few vehicle manufacturers to be certified, and for the market to start developing so that we can understand, is it thousands of vehicle per year market, or is it going to be, something like a Segway that where it's used occasionally and it has its value, but it's not mainstream or widespread.
Okay, understood. Correct. Mr. Agrawal, you have something to add to it?
So, yes. So, based on the projections that we have, so we do not, anticipate huge production rates. And the kind of production rates that we, production or deliveries that we are anticipating, we do not see, much issues in terms of supply chain.
Okay.
The moment anything goes above 2,000 or 3,000 units or eVTOLs, then there would be a lot of challenges. The reason being that the industry works a lot on quality, not on quantity. Also, increasing capacity needs a lot of investments. At the same time, those materials being certified for certain programs, so you must secure that capacity for certain programs. So a lot of factors being there. But as of now, we do not see any supply chain challenge, at least for next 5 or 7 years. Once there would be a lot of production, I think by that time industry will have some increased capacity and they are going to address it. So even they have 5-7 years learning curve, right? And next 5-7 years they are going to learn more. So they can manage easily, those supply chain constraints, even if it surfaces next 7 or 10 years.
Yeah, let me make one other quick point on supply chain.
Please.
Right now, the commercial aviation business is not back up to full capacity, right? Pre-COVID capacity.
Wow.
If you look at timelines, I talked about 27, 28. That's about the time frame that the commercial aviation industry plans to be back to full capacity. So I think there is an emerging bottleneck happening right after certification in 27, 28, is there may be very little capacity on the aerospace supply chain available for the eVTOL industry to ramp up.
Yes, correct.
Thank you. Thank you for that response, Dr. Yancy and Mr. Agrawal. Dear viewers, you can still put your questions on LinkedIn Live. I'll take the next question, Dr. Yancy. Dario has a question. Mr. Yancy mentioned automotive processes to enable productivity. Right? Can HPRTM help with sustainability as well as in terms of avoiding consumable wastes? Is there a future for this technology in eVTOL?
Yeah, great question. I think in general, the answer is yes. I mean, commercial aviation is looking, as I mentioned, there's a large program in Europe to look at can we do resin infusion for an entire wing box and so forth. And so I think infusion processes do have the ability to be able to ramp up production rates as well as, you have less waste with infusion processes. So we do see quite a bit of interest in this industry for infusion processes, and Hexcel remains active in developing in developing and producing infusion resins for those applications.
Okay, understood. Thank you, Dr. Yancy. Now this should be the last question that we're taking today. Kane has to ask this. In your opinion, what will be the key promising composite part production process type for eVTOL? For example, compression molding, thermoforming, overmolding, or etc. etc.
Yeah, no, another great question on this. I think it remains to be seen. One of the things that I get excited about with the development of this industry is that I think it will generate some new higher rate manufacturing methods than we have today. And so it could be compression molding, thermal forming, overmolding. All of these things I think are potentially new manufacturing techniques that we haven't even thought about yet. So I think this is pushing the industry. It's definitely pushing us as a material supplier to look at, how can we create material systems that are amenable to high rate manufacturing processes.
Okay. Thank you so much for that response, Dr. Yancy. I think this is it for today. Thank you, Dr. Yancy. That was truly illuminating. Your perspective throughout this session has helped us, better understand not just the general queries around eVTOLs, but also the material and as well as the operational side of it. Right? And with that, we come to the end of today's session. I really think this was a really meaningful and productive conversation. I hope you too had a great time, good time sharing your insights, Dr. Yancy and Mr. Agrawal.
Yeah, thank you very much for the opportunity, and appreciate the Stratview team for helping to put this together.
Pleasure is all ours.
Thank you, Vapak, for driving this session. It was really great. Thank you.
Thank you so much, Mr. Agrawal. And, we'd love to have more such sessions with you in future, Dr. Yancy and Mr. Agrawal both. Perhaps we can try, some other thing, like panel discussion or some other format. We'd love to host you again.
Yeah, happy to help.
Thank you. Thank you so much. All right, wrapping it up to both our speakers, Dr. Yancy and Mr. Agrawal. I express my sincere thanks for your time, your clarity, and for sharing insights that were both strategic and grounded in real-world experience. It is truly and indeed rare to have such a rich multidimensional view of a sector as complex and promising as the eVTOL industry. Also, to everyone who joined us today, thank you for tuning in. Whether you are an industry insider, a potential investor, or simply curious about the future of advanced air mobility, we hope this session gave you valuable takeaways. Meanwhile, everyone, keep track of our LinkedIn page to get notified in the future as we host such webinars on a variety of topics very regularly. Thank you, everyone, for connecting. Thank you, dear viewers.